Hello everyone, today we are going to discuss about the oxygen hemoglobin dissociation curve. So this is the picture showing the curve. The right side is depicted by the yellow and the left side is depicted by the green, and the black line is the normal curve and the grayish line is the myoglobin. So we have to know one concept. Whenever there is like we know that hemoglobin will carry 4 oxygen molecules, so there is affinity towards the oxygen. It is normal. So whenever there is increase in need of oxygen by the body, like in conditions like exercise, increase in temperature like in fever, high altitude, increase in PCO2, decrease in pH or increase in acidity, increase in 2,3 BPG, all these conditions will require more amount of oxygen release. So here the affinity of the oxygen by the hemoglobin molecule will decrease and more amount of oxygen will be released by the hemoglobin. And in left side dissociation, what happens is it occurs in conditions where there is increase in affinity towards the oxygen. Here the need of oxygen is less, there is less amount of oxygen release is required, like in decrease in PCO2, decrease in 2,3 ppg, decrease in temperature, increase in pH, alkalinity and fetal hemoglobin. So all these conditions we will see a left sided dissociation curve. So we have to know one thing, that whenever there is a left-sided dissociation, there is decrease in release of oxygen. So this decreased release of oxygen will be treated as a hypoxia. So this renal hypoxia, we know the kidney is the main site for the erythropoietin synthesis. So there will be increase in the erythropoietin synthesis because of this renal hypoxia, and this causes compensatory erythrocytosis. So in simply, we can actually say right-sided dissociation, there is release of oxygen. Left-sided dissociation, there is love towards oxygen, and increased affinity will cause us decrease in the release of oxygen.